Okay, as part of this unit, you're going to learn about the geometries and shapes of different molecules, including their angles. Now, students sometimes get all upset and they're like, why do I need to learn about the geometry of molecules? Well, the geometry, the shapes, are ridiculously important for molecules. So, if you're going to take a medicine, in order for that medicine to work appropriately, it needs to fit directly into a receptor that has the right shape for that medicine. If it doesn't have the right shape and the right functional group, sometimes we call it, then it's not going to work the right way. The way that we taste, the way that we smell depends on the shapes of those molecules. They need to fit into receptors to trigger some sort of a biological response. The way that the enzymes work within our bodies depends on the shape of the molecules they're supposed to act upon. So, shape is very, very important. Now, when we define the electron geometry, or the geometry of all of those bonds and lone pairs around some sort of an atom, what we're going to use is the term electron domain geometries. So, for the electron domain geometries, you have to understand what I mean by domain. So, a domain is a place where electrons are. For example, a domain can be a place where people live. This is my domain. There might be many of you in my domain, or there might just be me in my domain. When you think about your room is your domain. Maybe there's just one of you in your room, or maybe you share it with a brother or a sister, and there's two of you in your domain. Let's say you go to college. You might get a single. In that case, there's just one of you in your domain. Or maybe you have a roommate and there are two of you in your domain. Or you have a quad and there are four of you in your domain. Well, electrons are no different. For an electron domain, there might be 2 electrons in that domain, or there might be 6 electrons in a single domain. So what counts as a domain? A single bond counts as one domain. This is one domain. It just happens to be 2 electrons live in that area. A double bond is a single domain, one area where electrons live. There happens to be 4 electrons that live in that single domain. A triple bond is a single domain. There happens to be 6 electrons in that domain. And a lone pair counts as one domain. 2 electrons live in that domain. So let's get a little practice distinguishing how many domains we have, because the geometry depends on the domains. So if we start off at the beginning, let's look at sulfur trioxide. If I asked you how many domains around the center sulfur, you should say 3. There are 3 domains around sulfur. A single bond counts as a domain, a single bond counts as a domain, and a double bond counts as one domain. 3 domains. For the ammonia molecule, if I asked you the number of domains around the nitrogen, you should say 4. There are 4 domains around nitrogen. This is a domain, this is a different domain, a third domain, and a lone pair is the 4th domain. Let's try a couple more. What about around ozone? If I asked you for the number of domains around the center oxygen atom, you should say 3. 3 domains around that oxygen. Here's one domain. A double bond is a single domain. A lone pair is a single domain. A single bond is a single domain. And this one students often get wrong. If I ask you for the number of domains around the center carbon, you say 2. Hopefully you said 2 domains. A single bond is a single domain, and a triple bond is 1 domain, not 3. Hope that helps. Take care.